Hello, so today's problem is diameter of a binary tree. So for this task, I wanna use DFS, and I wanna use the following algorithm. So I wanna go DFS and go like, so we have 1, 2, 3, and then 4, and then 5, and I wanna go DFS and on every level. So like DFS down, down, and then here is a child node. So I start like probably down. I check if the node is a child, and if yes, I return the level equals like not level but the length or like distance. Distance equals 0 on the node, and I do the same for the right. Uh, go down, return back, return distance equals 0. At 2, I have like left distance and right distance, and I need to decide what. First, I'm gonna have a global maximum, Gmax, where I'm gonna update the current maximum distance, like global maximum distance, and here I'll have the formula to join those two distances with a node 2 in case this gonna have like, in case you have like really long like this kind of binary tree, this kind of. So the maximum path here, maximum distance, comes not from the root. In this case, it comes from this nodes, and that distance gonna be 1, 2, 3, 4, 5, 6. But if I go through the root, the distance gonna be just through the root. The distance gonna be just 5. So clearly, I need to close this distance for every parent node and check if the Gmax is less than current distance. So Gmax was 0 before that. So now I close it with this loop. I have left distance 0, right distance 0, but because it's like one edge away from the current parent, so I add 1 plus left distance plus 1 plus right distance. This equals 0, this equals 0. So finally I'm gonna have um, 2 here, maximum distance, and whatever I have here maximum, the left distance gonna be, I'm gonna update it to 1, like like left distance was 0 and here right distance was 0, and I'm gonna percolate back to the parent maximum between 1 plus left distance and 1 plus right distance. In this case, I'm gonna percolate back 1, so I return back like here 1. And then I go to the right, I meet the child node, so I percolate back 0, and here I gonna do the following. I'm gonna do the same kind of thing. I'm gonna check left 1, L distance gonna be 1, right distance, okay, here, left distance gonna be equal 1, right distance gonna be equal to 0, and I'm gonna check again this, um, what's closing, uh, like if I gonna do like this 3, oh, not this 3, let's say I choose left sub 3 here, so if I gonna do this 3, what's the distance gonna be here? So the distance is gonna be 1 plus left distance plus 1 plus right distance. And in this case, it's gonna be this one gonna be equal 1. This one's gonna be equal 0. So the answer is 1 plus 1 plus 1 gonna be 3. So I'm gonna check with the Gmax. Gmax gonna be updated to 3. And then I'm gonna choose whatever maximum I have. Here I have maximum 1 plus L distance and 1 plus right distance. In this case, this one 0, this one is 2, so we need to calculate back 2. But because it's a root node, I stop right there. So this is a sketch for the solution. So as I said, I'm gonna have int gmax um, and then I'm gonna call DFS for the root with passing gmax, and then current DFS gonna have private int DFS, and I'm gonna return gmax 0, and then DFS I'm gonna return root 3 node and then int gmax, and then here I'm gonna check if node equal null. I'm gonna return 0 if node left and node right equals null. Here equals null. I'm gonna return 0 the same, and then int left equal l distance equals 0, and then if node dot left not equal null, and node dot right not equal null. This one is a little bit confusing because this one will work only for the root. If I gonna include this case for all parents, I will not be processing so I'll be just assigning is gonna be the same as actually I can return -1 here. Yeah, return -1 here. And then I can skip this. So I can just do DFS node left and then int right distance DFS node right. And then I need to check gmax 0 equal max 1 plus L distance plus 1 plus right distance, and then return max L distance plus 1 and then right distance plus 1. something like this. We run it. Interesting. If I'm gonna do the same, but let's say I have this one is 0, if node left not equal null, okay, for the root equal 1 and 2, how it's gonna go? Mm. So here we should do the following. And here I should do also the following. Okay, that's it. Made a small mistake. I guess this is fail. Let me check the timing. Yeah, I guess this is fail because I made mistake and I ran it. I didn't paper test it again. So we need to have this, habit to do paper testing before hitting run button. Let me check what they have. Memory, memory not that good. Hmm. Okay, all right. Okay, if I'm gonna save it as a class variable, not class variable as an object variable. You will give me. Oh, okay. So it's gonna be less variable in a call stack. Mm, okay. There anything better than this? Not really. Mm. Okay, I'm gonna wrap up. That's it. As I said before, the status has failed because initially I solved the problem and then I tried to optimize it, but it was a minor mistake for the for the algorithm, and sometimes it can lead to the fail to the fail to the failing at the real like coding interview. That's it.